Hello, student. Welcome to Discourse CHM413 titled Analytical Chemistry 2. And this shall be our eighth and the last lecture in this course as far as this semester 2021 is concerned. So in this eighth lecture of virtual class, what are our intended learning outcomes? So at the end of this eighth lecture, students must be able to describe the history and applications of radioanalytical chemistry, identify the essential features, characteristics of alpha, beta, and gamma rays. Students should also be able to explain the basic principles of some radio analytical detectors and describe radioanalytical chemical principles. Recognize the importance of precipitation as a radio analytical technique. Describe briefly the basic principles of distillation, solvent extraction as a radioanalytical separation method. Students should, however, appreciate ion exchange as a veritable separation method in analytical studies, as well as to explain the term electrodeposition in relation to separation method. Students are therefore encouraged to listen or even study the instructional video prior to the online virtual synchronous class that has already been scheduled for 25th of May 2021. Having gone through the instructional video, are there areas of difficult to comprehend? So these are the areas students are expected write down their questions so that in the virtual synchronous class, students can now present those questions for maybe further explanation, elucidation by the facilitator. So thank you for listening. Thank you for participating in our lecture series. So I remain your facilitator, Dr. Emeka C. Ogogo. Hello, students, once again. So this is CHM413 Analytical Chemistry 2, as earlier stated or mentioned. Our topic today will be radiochemical methods, presented by your facilitator, Dr. Emeka C. Ogogo. The intended learning outcome had already been mentioned or stated. However, we will still need to state it again for the purpose of emphasis. By the end of this lecture, students would have been able to describe the applications of radioanalytical chemistry, identify the various essential features of alpha, beta, and gamma rays, describe the basic principles of some radiation detectors, and describe radioanalytical chemical principles. state the importance of precipitations as radioanalytical techniques, um, state the basic principles of distillation, solvent extraction, method ion exchange as a veritable separation method in radioanalytical studies. Then finally, uh, explain the term electrode deposition, especially in relation to separation method. And radiochemical methods. Radioanalytical chemistry focuses on the analysis of sample for their radionuclear content. Chemistry as well as nuclear procedures have been applied to elucidate nuclear properties and reactions. Reactions use radioactive substances as tracers and measure radionuclides in many different types of samples. The applications of radioanalytical chemistry, therefore, are one, forming and characterizing new elements. So, new elements can be formed and characterized by these techniques. Two, determining the age of materials. Three, creating radioactive reagents for specific tracer used in tissue and organs. In interactions of radiation with matter. Interaction of radiation with matter. The detection and measurement of radionuclides is mainly based on observing the emitted rays or particles. Interaction with matter involves a transfer of energy to atoms and molecules. This interaction can cause ionization or excitation of both. The interaction depends on the type of particles or photons involved, the energy of radiation, the properties of matter, the thickness of radiation absorbing materials is of utmost interest and is given in surface density or weight per unit area. Alpha particles. Alpha particles. Alpha particles have a high mass. We are looking at the features of alpha particles. Alpha particles have a double electrical charge. Alpha particles lose their energy rapidly as they pass through matter and leave a dense thread of ionized materials along their ways. Alpha particles, therefore, have very small range in air, a few centimeters in air. The range of alpha particles is similar to the range of energy transfer, which is very high. Alpha particles can easily be stopped by a certain thickness of shielding material. Alpha decay is characterized by the emission of an alpha particles with a helium nucleus. The mode of this decay causes the parent nucleus to decrease by 2 protons and 2 neutrons. Beta particles, we want to look at the features of beta particles. What are the features? What are the properties of beta particles? So beta particles have a single electrical charge. Beta particles have a much lower mass compared to the alpha particles. The beta particles have maximum range in matter of 1 megavolt. Initial energy is approximately 3 meters in air or 4 millimeters in water or animal tissue. Beta particles are much more readily deflected by collisions with atoms and molecules. Beta decay is, however, characterized by the emission of a neutrino and a negatron, which is equivalent to an electron. This process occurs when a nucleus has an excess of neutrons with respect to protons. Gamma and X rays. Gamma and X-ray photons. Gamma and X-ray photons have low interaction with matter. As a result of this, they have much more penetrating power than particulate radiations of the same energy. The absorption of gamma or X-ray photons is quite complex, and the mechanism depends on the photon energy, one, two, the atomic number of the element or matter involved, the density of the absorbing materials, and the most important aspect of interaction with matter at low energy is what is called photo effects. Photo effects. Now, the gamma ray proper. The energy of a photon is converted into the kinetic of the orbital electrons, which in turn is ejected from an atomic shell by interaction of the photon. The kinetic energy of this photoelectron corresponds to the energy of the gamma photons minus the binding energy with which the electron was held initially within the electron structure of the molecules. The photon electron will dissipate its energy into matter similar to a beta particles. Kapton scattering is another mechanism by which gamma photons lose their energy. A part of the photon energy is converted to kinetic energy of an electron. The rest remains in the form of a scattered gamma photon of lower energy, which may undergo interactions with different atomic shells, producing a photon electron or another Kapton energy or electron. These separation methods include radiochemical separation techniques include precipitation, ionization, or ion exchange technique, liquid-liquid extraction technique, solid phase extraction, distillation, and electrodeposition. Now let's look at precipitation as a radio analytical or radiochemical separation techniques. Precipitation, solids can be formed in a solution or inside another solid during a chemical reaction. So the process is called precipitation, and the solid formed in a liquid is known as precipitate. Precipitation occurs in chemical reaction when an insoluble substance is introduced into a solution. The liquids remaining therefore above the solid is called the supernectar or supernectant. Supernet or supernectant. Precipitation is enhanced as the solution becomes supersaturated. Relative supersaturation is given uh, by mathematical expression Q minus S all over S, where Q is the total concentration of the solutes at any instance. S is the equilibrium solubility. The particle size of a precipitate varies inversely as the relative supersaturation. Precipitates are formed by nucleation and by particle growth. Nucleation is therefore a process in which a minimum number of atoms, ions, or molecules join together to give a stable solid. Nucleation increases with increase in relative supersaturation. When nucleation predominates, a large number of fine particles results. If particles growth predominates, a small number of large particles is therefore obtained. The filter paper is supported by a glass frit clamped between two glass tubes. The filter paper used in the filtration must be treated with all the reagents beforehand, dry and weighed so that any material loss in filtration is minimized. The precipitate is washed finally with acetone or alcohol and dried in an oven. The precipitate should not absorb water or carbon dioxide so that an accurate weight can be obtained. So, therefore, it is advisable that the precipitate should be placed in a desiccator. And the first class activity, students are therefore expected to state how low concentration yielding of radionuclide can be circumvented. Distillation is another radiochemical separation technique. Distillation is a technique of separating mixtures based on differences in volatilities of components in a boiling liquid mixture. Distillation is a physical separation process and not a chemical reaction. The separation of components in a mixture whose partition coefficients between solution and vapor phases differ greatly can only be achieved by distillation. The separation process is very simple if one species has a partition coefficient that is large compared with the other components of the mixture. A fractional distillation procedure is required for those systems in which the difference in partition coefficient is small. The next radiochemical separation technique is solvent extraction. In solvent extraction, a solute can be separated from a solution by shaking a solution with solvent in which the solute is more soluble. The extent to which solutes distribute themselves between two immiscible liquids differs greatly, and this difference have been used to achieve separations of chemical components or species. The distribution ratio, otherwise known as partition coefficient, is equal to the concentration of a solution in the organic phase divided by its concentration in the aqueous phase. The distribution ratio depends on temperature and the concentration of chemical species in the system. Application of solvent extraction. Multi-stage counter-current continuous process is used for metals such as the lanthanides, mainly because the separation factors between the lanthanide are so infinitesimal and many extraction stages are required. Organophosphates, tri-N-butyl phosphate, are good and common solvents for multi-stage counter-current continuous process. Other solvents that have been used and they are still being used and they have also proved to be good are ether in extraction of uranium, tributyl phosphate as an extractant for uranium and palladium. Class activity 2. Students are required here to enumerate two differences between distillation and ion exchange technique. Another analytical technique uh, or radiochemical separation technique is known as electrochemical deposition. Here, it is a process by which a film of solid metal is deposited from a solution of ions onto an electrically conducting surface. Electrolysis or electrochemical deposition can be used to blend out active material of interest. Electrolysis or electrochemical deposition can also be used to plate out other substances, thereby leaving active material in solution. Ion exchange technique. Ion exchange is a method of separation, purification, and decontamination of ions containing solution using mineral exchangers or solid polymers. Ion exchange has high selectivity and better ability to perform separations rapidly. A solution containing the ions to be separated is therefore brought into contact with a synthetic organic resin containing specific functional groups that selectively bind the ions in question. Organic ion exchangers have reactive groups such as hydroxy group, carboxylic group, or sulfonate group and are insoluble in water as well as organic solvents. These exchangers should have an open, permeable molecular structure so that ions and solvent molecules can move freely in and out of the molecular structure. The ions to be removed from the resins by elution with suitable solution that differs from the initial solution. Questions. Uh, so characteristically, the solution containing the ions is run through a column packed with resin beads. The resins are usually cross-linked polysterenes with attached functional groups. Most cation exchangers, such as Duwex 50, contain free sulfonic acid groups, where the cation displaces the hydrogen ion. Anion exchangers, such as Duwex 1, contain quaternary amine groups, such as a group of ions can be absorbed on the column material and then selectively eluted. Eluents are complexing agents which form complexes of variable solubility with the absorbed ion. Competitions usually exist between the complexing agents and the resins for each ion, and each ion will be exchanged between the resins and the complexing agent in succession as it moves down the column. Spatial separation between bands of different ions occur due to the different rate at which ions migrate down the column. In conclusion, we therefore conclude by observing that interaction of radiation with matter depends on factors such as the types of particles, energy of radiation, and the properties of matter. Gamma and X-ray photons have much more penetrating power than alpha and beta radiations due to low interaction with matter. Radioactive nucleotides have chemical properties similar to their stable counterparts. Consequently, similar analytical separation techniques are employed. In summary, analysis of sample for their radionuclide content is a base principle of radioanalytical chemistry. Interaction of radiation with matter can cause ionization or excitation, which therefore depends on the type of particles, energy of radiation, and the properties of matter. Alpha particles have very small range in air, and the range of energy transfer is very high, but can easily be stopped by a certain thickness of shielding material, while beta particles have maximum range in matter, but much more readily deflected by collisions with atoms and molecules. Gamma and X-ray photons have low interaction with matter. As a result of this, have much more penetrating power than particulate radiations of the same energy. Precipitates are formed by nucleation and by particle growth, and precipitates have very low solubilities. Separation of components in a mixture whose partition coefficients between solution and vapor phase differ greatly is made possible through distillation. Solutes distribute themselves between two immiscible liquids at different rates, and this physical property is very important in chemical separations of chemical substances such as lanthanides via solvent extraction techniques. The inherent nature of radionuclide yielding low concentrations is oftentimes circumvented by pretreatment of glasswares and by addition of inert carrier or by tracer addition. In ion exchange is a method of separation, purification, and decontamination of ion containing solution using mineral exchangers or solid polymers. Substances can be plated out, thereby leaving active materials in solution through a radioanalytical technique known as electrochemical deposition. At this point, we draw the curtain. So thank you for listening while I wish you successes in your examination. I remain your facilitator, Dr. Emeka C. Ogoko.